one's pretty good. Okay, so you can read it. If you want to write, it will take some time. Yeah, it's quite a few questions, huh? So, take 3 minutes, whatever, to write it down, think about it, then we'll do it. So are you going to do that? The teacher suggested to you to find these people that not only they are living in the present and they are not worrying at all, but also almost all the time they're actually top students. Are you going to find them and tell them, teach me, tell me, how do you do that? Are you going to do it? Or are you going to just continue being in a sorrowful, confused, depressed, gloomy, sorrowful state? Does it make any sense not to do it? What hinders us to do it, not to do it? What makes us not to do that? Go and find someone who will see the way he acts is so much more than the way we want to be, and we don't go and say, tell me, what is it that hinders us? What is it? What is it? One word. One word. Fear. Another word. Pride. Another word. Huh? I. So we need to eliminate these things. That's your only goal in this life. There is no any other goal more important than to eliminate these things. Because when you do, everything is going to be so beautiful and successful. So anyone who does not work on this goal is wasting his her time. That is for sure. And what is along the road, there's a lot of sorrow, a lot of crying, a lot of beating. Guaranteed, unavoidable. See people, look at relatives. Open your eyes and look at the relatives, your parents, your, all people that are around you, more or less what is happening in their life. Look at them, what they're doing. Examine why they are in troubles. Why? Just step back and see, ask yourself, why? And you will see that always these three things that the student said is the reason. When you eliminate this, you will fly. Sky will be the limit for you, for everything. Are you ready for me now? You write it down? So it says, deduce the rate laws. We know the experimental rate law, what it looks like, right? Proportional to each of these two reactors. We know what the experimental rate law is, and we want to deduce. So somebody suggested 3 different mechanisms, right? So maybe it's happening this. Are these, let's go, first question. Are these mechanisms reasonable? The first thing that you ask is if they're reasonable. And when we say reasonable, it's the first thing that we can see just by looking at the paper. We don't have to go to the laboratory, right? Are they reasonable mechanisms? That's the first criteria now we're looking at. That's not experimental, actually. It just makes sense the way we wrote it, right? So are there reasonable mechanisms for this reaction that is represented by this general chemical equation? Yes or no?
Yes.
Yes. Everybody agrees?
Mm-hmm.
How many people do not know why? Raise your hands. So everybody knows. I'm not going to explain it, right? Why is that? Anybody tell us? Because, why? Yes, if you add the different steps for each mechanism, what comes up is the overall chemical equation, right? Okay, so they're all reasonable. They're reasonable mechanisms. Because the first criterion is met. Now, there is another criterion, and that's called the experimental rate law. It has to match with the rate law we will predict by looking at these cartoons. For each of these cartoons corresponds the rate law. Now we know how to derive it. Each proposed mechanism corresponds to a rate law. So let's find out what these rate laws are for each of these mechanisms. Right? That's what the problem is asking us. We know the experimental rate law, but we're going to see the rate law for each of these mechanisms, what it is. So, first one is really easy, isn't it? What do you do for the first one? The first one will be, it's the first one step. So what does it mean? It's very easy. We're just looking at the one equation, right? And we say what? Rate is going to be K times A2B2. Concentration of one reactant times the concentration of the other reactant, right? If it's one step, then one here, one there. Why? Because the equation has 1 and 1. One here, one there. Can you see them? These are the ones. Okay, do you see these ones there? That's why, if it's one step, it's going to be like this. Great. Now, how about the second mechanism? What is the rate law that corresponds to the second mechanism? Well, the second mechanism, if you notice, is a two-step mechanism, and only that. But the first one is fast equilibrium, proposed step, and that one is proposed to be a non-reversible reaction, quantitative reaction, slow. So the way we did that in lecture, you remember? What did we do? We said that the rate of the reaction, in this case, rate of the reaction for this mechanism, the overall rate, is going to be the rate of the slow step. And if you go to the slow step, because each step of every mechanism is a single step, an elementary step, then we can derive it by looking at it. So here is the slow step, and therefore it's going to be B squared times concentration of the other reactant A2, right? So the rate then for the second mechanism, it will be the rate of the slowest step. The slowest step. There's two steps. One is fast, the other is slow. So it will be then, therefore, rate of the second step will be K2, and it will be B squared times A2. And we say now that the rate should be a function of only reactants. And in this case, the B, as you can see, is what? Is an intermediate. We don't want to have a B there. So the only way we can get rid of it is to do the trick that we did in lecture, or a similar one. In lecture, we said the rate of the forward is equal to the rate of the reverse. Do you remember? Rate constants, and we solve for the concentration of the intermediate. Do you remember that? It's really the same thing. It's the same thing. And it's actually probably faster to say for the first step of this mechanism, the equilibrium step, we can write the equilibrium constant. So the equilibrium constant for this is going to be what? As a constant also, right? Just like the rate constant is a constant. So equilibrium constant will be what? K equilibrium is going to be equal to B squared divided by B2 molecule concentration. And from here you can solve for B squared should be equal to K equilibrium times concentration of B2. So now you go to rate equal to K2, right? Times B squared, A2, times B squared, which is this, times A2. I put them in parentheses like that to see clearly what we're doing. That's the only reason I do that. So now you have what? K2 times K equilibrium, B2 times A2.